Okay, so it gives us a warm up. What we're gonna do, I'm not gonna do this warm up right now. So this is gonna be a daily grade. When you turn it in, it will count as like its own daily grade, separate. So you can kind of do that on your own because it's just more synthetic division, synthetic division, synthetic division. These two have remainders. And just finding f of 9. That's it. Okay, so let's move on to the actual notes. So, okay, so today we're going to do remainder theorem and hopefully factoring theorem. Hopefully we have time. Okay, so remainder theorem says if a polynomial function f of x is divided by x minus c, then the remainder is f of c. So we can check our functions this way. So using synthetic division to evaluate a function is called synthetic substitution. Synthetic substitution. All right, so look at number 1. It says use remainder theorem in synthetic substitution to evaluate f of x at c. Okay, so if c is -3, we're going to evaluate this function at this, -3. So use synthetic division. Oh my gosh, I'm in the crack again. Here we go. Okay, so we have -3, and then we're just going to do our synthetic division. Bring down your variables for each one. So we have 1, 8, 12, -7, -14. Start by bringing down your 1. So -3 times 1, -3.
You forgot the 1 on the 14.
Oh my gosh. There we go.
Is that a +1?
I think so.
Hey!
I like that you guys are paying attention. That's why I give the bonus points for my mess ups. I want to know who's paying attention. Okay. Oh, Blake. You got your answer, Blake, right? Sorry, I just saw the chat. Upload it to 3.5. I think you did. I think I have yours. Okay, so here we go. Let's keep going. 1 times 3, -3. Combine, we have 5. -3 times 5, -15. Combine, we have -3. -3 times -3, 9. Combine, we have 2. -3 times 2, -6. Combine, we have -20. Everybody with me? Okay, so looking back up at our remainder theorem, okay, so if the polynomial function is divided by x minus c, the remainder is f of c. So we just did f of c, and we got -20. So then if we were to divide this function by x minus c, so x minus 20, we would get this. So you just basically can check it. Now you can go plug it in, and you should get -20.
Wait, what?
So you plug in -20 to the equation and you should get -20?
No. You would have to divide it. You would divide it by x minus c. So if we said x to the 4th plus 8x third, and so on, all the way back here, this whole thing, if we divided this by x minus 20,
Yeah.
well, x minus -20 rather, then
I'll just take a number 1.
our remainder would be f of c.
Yeah.
Okay, Blake, I got yours. Sarah, I got yours. We're just using synthetic substitution to do it.
So it's x to the fourth plus 8x to the third plus 12x squared minus 7x minus 14 divided by x plus 20 because it's x minus negative 20, and you should get f of c. But what is f of c?
Well, on these, it's nice and easy because they gave it to us. And our f of c is -3.
Okay, that makes sense.
Yes.
So do you not have to do anything on like these? Like you just have to do the synthetic division?
That is it.
Okay.
If you want to do both, you can do both.
Okay.
Here, we're just practicing plugging in f of c.
Okay.
Okay, so for this one, it's going to be the same thing. We're going to plug in f of c for this function. We're going to get a remainder. All right, so whatever our remainder is, if we did x minus our remainder, then we would get the same thing. Okay, so look. Here we go. So I don't have to write so much and my pencil is dull. All right, so here we have c is 1, okay? Bring down all of your coefficients.
Mrs. Herrera,
Uh-huh.
which packet is this? The one on the screen right now?
Oh,
Sorry, I'm in-
3.6.
3.6. Did we get that in class?
No, it should be in the Google Classroom. So if you don't have a way to,
Oh.
you can just write the notes on paper.
Okay, thank you.
Sure thing. Okay, so let's talk back through this one. So here is our C. Our C is 1. All right, if we divided this by x minus 1, then we would get the remainder 11, which would be our f of 1. It's just a way to double check it. That is all. And they have a lot of examples. I don't think we're going to get to all of them. So on 5, 6, 7, and 8, we are just doing synthetic division on all of them. That is all. I do want to look at number 7 because it's a little bit different. And then we're going to move on to factor theorem because these are very redundant. Okay, so let's look at number 7. Okay, on 7, if we plug it in here and do f of c, so f of 7, and we're going to divide it x minus c, excuse me, here, and we bring down all of our variables. Here, first of all, we have a 0. We have no x term right here, so we're going to add a 0 in. Okay, now when we start doing this, we start getting really big numbers. And sometimes you're going to get that because when you have more real life problems, it's not always going to be like -5 or what were some of our others that we just did? 11 or 20. Sometimes it's going to be some really big numbers. It just depends on what the problem is asking. So if you do get a really big number, that's okay. So as you can see, this grew really quickly, really fast. We brought down our 8 and we got 56 and then we had 51. So now we're multiplying 7 times 51. And then we get 2,499 and that's okay because that's actually our answer. Okay, so I want to look at number 9 now. Okay, so this says the number of tickets sold during the high school football season can be modeled by the equation f of x equals x cubed minus 14x squared plus 72x plus 68, where x is the number of games played. Use the remainder theorem to find the number of tickets sold during the 7th game of the season. So our x is going to equal 7. So here we're just trying to figure out how many tickets are sold during the 7th game of the season. So we're evaluating for x equals 7. So you can come do synthetic division, or you can plug it in and do all this, and you're still going to get the same answer. It's much easier to do it this way. So write out your coefficients, add your 7 for synthetic division, and you end up with 229 tickets sold. So I wanted to do this one because it shows you that sometimes you do get a big number, and that is correct. Easy enough? You're just solving for the equation for whatever they're asking for. That's all. So like on number 10, it says the distance in feet that a person travels on a snowboard is modeled by the equation. The distance, or d of t, equals 0.6 t squared plus 10t, where t is time. So use the remainder theorem to find the distance traveled after 1 minute. Okay, so here our t is time in seconds. So this is the first thing you need to look at. Time in seconds. So it says it's now asking us after 1 minute. So 60 seconds in 1 minute. So we're evaluating x equals 60. So plug in 60 for your x. Add all of your coefficients, 0.6, 10, and 0, because we have nothing after this. Bring your 0.6 down and solve. So the distance it traveled after 1 minute is 2,760 feet. And we know it's feet because it says right here, the distance in feet that a person travels. Okay, let's move on. All right, this next part, again, we have another warm up here. Sorry. Okay, another warm up. I cannot get straight in this camera. All right, so this we're not going to do right now. I'm taking this one as a daily grade also. Maybe I'll take them as quiz grades. We need another quiz. I don't know. Okay, oh wait, that's the same thing. Hold on. Sorry guys, I put up the same packet. All right, now we're doing factor theorem. Here we go. Factor theorem. All right, given a polynomial, the factor theorem is given a polynomial function, f of x, x minus c is a factor of f of x, if and only if f of c is 0. Who remembers geometry? You had these statements in geometry, if and only if. +1 for anyone who remembers what they're called. Anybody remember what the if and only if statement's called? Nobody remembers? Blake, nope. Yep, okay. If you want to go look that up, not right now because I don't want you to miss the notes, and you want to email it to me, I will give you a +1. If and only if statements. All right, so given a polynomial function, f of x, x minus c is a factor of f of x. Well, we know that because back here when we did them, even like the ones that you just did.
Miss Herrera,
Yes?
is the if and only if statement, does that mean that like it only works under one condition?
Yes, it does. It only works under one condition. So what, for the bonus points, I'm asking what it's called. There is a name for it. So we know that it's a factor okay? Because we did some of these problems where it was a factor. Okay, so let's look at the test. Test
Is it biconditional?
is biconditional. Good job, Lexi. Add that on your thing. Okay, so test for factors. All right, so if our f of z, if our f of c equals 0, then it's going to be a factor. So look at number 1. You are going to you're going to solve, okay? And then we're going to check each x value. And if our f of c is 0, then it's going to be a factor. Gotcha, Anaya. Okay. So coming back to this. All right, so first we're going to solve. So here, let's look at these. They've given us x plus 1, x minus 5, and x plus 6. So let's check for factors for these. So for our x plus 1, we would plug in negative here because we do the opposite, right? Okay, so bring down your 1, do all of your synthetic division. We have 60. 60 is not 0, so x plus 1 is not a factor. Here we have x minus 5, plug in positive 5. Do your synthetic division. We end up with a remainder of 0, so x minus 5 is a factor. X plus 6. Plug in your negative 6, we get 0, it's a factor. Here we go, look at number 2.
Can you like raise it up just a tiny bit?
Oh, yes. More?
That's perfect.
Okay, so here they've given us x minus 2, x plus 7, x plus 4. It's nice they're giving these to you, don't have to find them. Okay, so let's start with x minus 2. So we're going to plug in positive 2 and we're going to check it. Yes, it is a factor. Look at x plus 7. When we plug in negative 7, it escalates very quickly to a very large number. It's not a factor, but it's one of those problems we got a very large number. With a remainder. And x plus 4 is. Okay. All right, so let's look at one where they don't give us all of the choices. Okay, so look at number 3 here. Okay, so here they've given us this polynomial function, x cubed plus 3x squared minus 4x minus 12. And they've given us that x plus 3 is one of the factors, okay? So we're going to use the remainder, the factor theorem to factor it completely. And then it says, then give the zeros. All right, so what we're going to do here is we're going to divide the rest of the polynomial function by x plus 3 using synthetic division. So we're going to take our opposite here, -3, and we're going to use synthetic division to solve this. So we know x plus 3 is a factor because they told us that it was right here. So of course we get a remainder of 0 there. So we're going to come over here. We did this in the last section. Nothing has changed. It's just looking at it a little bit differently this time. Okay, so we're going to come over here. We're going to start with x plus 3. So now what is left? Well, here we have x squared. We have nothing for x. And then we have -4. And of course, we have a remainder of 0, which we knew we were going to get. So we have x plus 3 times x squared minus 4. Now we can factor this part to x plus 2, x minus 2. And then here are our zeros, -3 and plus or minus 2. So it's nothing different than what we've already done. Here, they're just up here, they're just asking you to check for it. They gave you some that are and some that aren't factors. And here, these are more of the problems that you would get where it asks you to factor it completely using synthetic division to check it. Okay, can we go to the next page?
Yeah.
Okay. All right. Let's see. We're going to do another few examples. If you ever get one with a remainder, then you know the factor they gave you is not a factor. Wait, the -6 one. Oh, okay. Blake, let's go back and answer your question real quick. Are you talking about this one? The -6 one? Oh, never mind. Okay, never mind. I figured it out. All right, good. All right, so here on number 4, it tells us that we have one of the factors is x minus 5. So we're going to use synthetic division to finish factoring this function. If you didn't want to use synthetic factoring to factor this polynomial all the way, you could draw your line right here and factor it by grouping. There's always more than one way to solve a problem. Okay, so we use +5. We're going to do our synthetic division. We got a remainder of 0 because we know this is a factor. So then we come over here, we write our x minus 5. That's our first factor. What's left? X squared plus 3x minus 4. We have no remainder. Then from here, we can factor this part. We have x plus 4 and x minus 1, and here's your zeros. Is everybody good to go on this?
I haven't finished writing yet, but I understand it.
Okay, perfect. Okay, so I want to look at one more that is quite a bit bigger problem.
Ms. Herrera, can you go back?
Yes, I can.
Thank you.
Sure thing. Okay, are we good?
Yes.
Okay, let's look at this last one. And then we're going to talk about the homework. Okay, so here they give us x minus 3 as a factor, and they have a very long polynomial function right here. So we're going to evaluate it at 3. We know our remainder is going to be 0. So here's your first factor. When you go to write this down, since we have 4x to the 5th, we have no missing terms. We're going to start our answer at the 4th. So we're going to have 4x to the 4th. Now we have a missing term, so we're going to skip x cubed. Then we have minus 13x squared. We have a 0 here for x and plus 9. So we end up with this. Now we're going to factor this. Break it down to 4x squared and x squared. And break this down to minus 9 and minus 1. So here are your two other factors. Now you can solve. So we have plus or minus 2/3, plus or minus 1, and positive 3. So even if they get big, it's still nothing different. All right, everybody good to go? Let's talk about the homework. All right, so, okay, so look at, here's the homework that is worked out. Okay, so on number 1, it's just asking you, oh, it would help if I moved it down, to use the remainder theorem to evaluate the function at C. It gives you C. You are evaluating this function at C using the remainder theorem. And the remainder theorem states that whatever f of C is, which is what we're finding, that is what your function is. So take your remainder, that's your answer. That's all it's asking. Okay, so then on 5 and 6, it's going to ask you to evaluate each of these factors and tell if they are actually a factor of this function. So remember, if you get a remainder of 0, they are. If you don't, they're not. Okay, on 7, it's going to give you one factor. That is a factor. So when you plug it in and do your synthetic division, you're going to get 0. If you don't get 0, you did something wrong. Then you're going to use that to factor the rest of your problem until your zeros. So that's 7, 8, 9, and 10. And then 11 is a word problem, just like the one we did a second ago. So if you wrote that one down, you should be good to go. Any questions?
No, ma'am.
Okay, so this assignment was good for today because it's literally the same thing that we've been doing. Now we're just looking at it from a different angle. Okay, so that's it. We'll go over the homework at the beginning of Thursday. And then I think because this assignment was kind of redundant. So after we go over the homework at the beginning of Thursday, then we will have I'm trying to decide. I meant to have y'all don't look at my dirty kitchen. I meant to have a quiz a test on Thursday, but I don't know. We'll see. What do you guys think? Can we take the test and move on, or do you want to push it till next week?
I think we could take it this week.
I think so. It's if you feel like you did well on the daily grade assignment, I think that you should be good to go with this test. Today's lesson was just more of the same. So questions? No? Let me know if you have questions. Okay, so let's plan for that test Thursday and we'll just knock it out and we'll move on to something different. Okay? All right, so the only homework is the packet and we didn't do all the examples. So as long as you have some of them done, that's good enough for me. So upload it all into 3.6 when you're finished and I will see you Thursday.
Bye, Ms. Herrera.
Bye guys.
Bye, Ms. Ferrer. Thank you.
Bye. Have a good day. See y'all.
Bye, thank you.
Bye.